p-value, which is the actually achieved size of the test. How do you figure out the achieved size of the test? The thing you do, you go through all, thing is, you go over here, and now what I do is I haven't picked this in advance, right? I haven't picked the size of the test in advance. And I'm going, okay, when is this? I go, okay, I get my data, I compute all this stuff, and then I go, okay, how extreme is this value that I see in either one of these scenarios? I go, how extreme is it? So basically, what I'm saying is, I go back to this graph, and I go, okay, if everything was hunky-dory, I make this transformation, I'm testing against 0, which is basically standardized value under the null. And I'm going, okay, so I look at this, so I go, where does x bar minus mu naught over s over the square root of n fall in this picture up here? So I go, okay, wherever it falls, I go, okay, say it falls over here, right? If this were true, then this has to fall in here somewhere. And let's say it falls right there, okay? And then I say to myself, under this scenario, let's say scenario 2, under scenario 2, if I set up a t-test at alpha, then basically I'd reject this as if this was less than, for a fixed, so for a fixed alpha, if this fell over here, what would I do? Would I accept the null or reject the null? Accept the null, right? But then I think to myself, well, basically, okay, let me look at this value. Say that falls right there, and then I could say, okay, if this were the cut point, what's the area under here?
Beta.
Right? That's alpha. Again, it's alpha, but I didn't fix alpha in advance. Remember, I said I'm not going to fix alpha in advance. So I say, so how extreme is this value? That's all I want to know. How extreme is this value? And the thing I do is I say, okay. So I go, what's the probability that t is greater than x bar minus mu naught over s over the square root of n? Okay. So back in this example that I had with cats. Okay, so say we're doing this test again. Say we're doing the plus one, all right? I go plus. So I'm doing so if basically I'm saying is if my mean is, so the thing I'm going to do is I go, okay, the thing I want to do is look at this thing. I want to know the probability. So I want to go, okay, PT, I said. PT.
Can you show us what you're doing?
Oh, that would be nice, wouldn't it?
Only just a lot.
That's asking a lot, isn't it? So how do I calculate, oops, that's not going to work either. The thing I want to do is calculate when's this an extreme value? I want the probability of T greater than whatever it is I observed, right? How do I calculate that? So I go, okay, come on down. Did I put it down yet? No, that's put them down. PT. So I go, okay, how extreme is this value that I got? So I can go, okay, what's the mean? Mean of H weight? what level was I testing? Can you see it? The mean of H weight minus, what was I testing at? Say 11.2, correct? Minus 11.2 divided by SD of, divided by SD of H weight slash SQRT of 144, paren, PT, okay,
I feel like
is that right? Oh, how many degrees of freedom do I have? I gotta put that in there. That's 143. And I wanna know if it's an extreme value, so what do I have to do? I have to go 1 minus that, right? This gives me the probability less than this. I want the probability greater than that, so I subtract off that. And what should I get? I go, I don't wanna run this thing. Hopefully I type it correctly and I'll get an answer. Unexpected, something. What do I have? Mean HWT minus 11.2, but.
there's a
Forgot something of that. Oh, that's what I need. I think that'll do it. I'm gonna be careful with all these things. There we go. Hope I did that one correctly. Let's see what happens. So basically, I'm gonna be saying, let's test it. Now you can do all this stuff, and here's a fast way to do it. Okay, I'm going to show you a command. I want you to, well, let me see what happens here. I don't hope I got the right thing there. Did I do that right? I wanted the mean. What did I want to compute? The thing I want to compute over here is, so the p-value is going to be the actual achieved value. So basically, I want the probability that t is greater than x bar minus mu naught over s over the square root of n, alright? So this is equal to 1 minus, what did I say, pt, 1 minus pt of x bar minus mu naught over s over the square root of n with n minus 1 degrees of freedom, correct? That's how you compute that in R. Did I do that correctly? Who knows? Find out in a second. You can do that. Now the thing, here's the thing. You can go some people know this command already, but I can go t-test. And I want the variable to be h weight, okay? And what do I want to test at? So I want t-test h weight. Well, I'll show you what it looks like. Okay, get the T in there, do that. So, here's why this one didn't blow up. So the test command, if you do that in your computer, it's going to go, here's the t-test. X is going to be, X is the numeric vector of data values that I want to test. Y is if I want to do a 2-sample t-test, then I throw in Y. This is the alternative. You have to state what the alternative is. Is it two-sided? Less? Is the alternative two-sided, or is it less or greater? Now I'm going to specify the mu that I'm testing against, and there's some other variables I'll get to, but when later thing. So we're going to just do a simple t-test. So over here, I can go t-test. Okay, what's the one I'm doing? HW weight, that's the variable I'm testing, right? There you go, what's the alternative hypothesis in this case that I was testing? Let's say it's,
are you doing a less than 11.2?
I think the one I was doing was that the alternative was, the one I was doing, I think, was greater than, I was doing it first, I was doing one, but it was, say greater. The alt is greater, whoops, the alt is greater, and here we're gonna have mu is equal to 11.2. See what happens, I'm gonna run this thing, hopefully it'll run. There you go, we did it correctly, okay? So here, it gives you everything. Okay, so let's see. So for your homework, I want you to do everything by hand, okay? I want you to do it the long way, and then you can check yourself looking at this, okay? And then in real life, you can always just do this and not have to do it the long way. But the thing I want you to learn is to understand what the output is, right? You can't, unless you can understand what the output is, it's hard just to use a canned program, because then you look at it and you go, what does all this stuff do?
So
Yes.
so what do you want turned in? Do you want our calculations the long way and then
Yeah, I
the
want you
same
to
thing
do, I want you
again
to do everything this way, like I have on the blackboard, and then you can check yourself.
But, so you want both in the homework or just the long way?
Just give me the long way, because I want you to be able to, okay, so over here, I go, here's the t statistic, it's minus 2.867, right? So what does that refer to? That just refers to x bar minus mu naught divided by the square root of s over the square root of n. That's what the t statistic is, right? That's the actual transformed to the t-scale mean that you observed, right? Degrees of freedom, 143. Well, we knew that. We had 144 observations, so the degrees of freedom is 143. Then I'm saying, okay, here's this thing that I observed, which is minus that, which is about right. So I got 10.34 for the, I got a 10.34 for the mean, correct? So I know 10.34 minus 11.2 is a negative number, correct? So yeah, so that makes sense, okay? Now look at that, here's the p-value. So basically I was testing, what was I testing? I was testing 1 over there. And I went, okay, is it less than 11.2 or is it greater than 11.2? Well, basically I wound up with a negative number. So the p-value then should be, so x bar over here in this case, that special case that I had, what time is it? Oh, we're at 10. So actually, in this case that I had x bar is equal to 10.34. Mu naught was equal to, this is the scenario I'm looking at, is equal to 11.2. So the t statistic in that way, so t is equal to x bar minus mu naught over s over the square root of n. And so in this case, for my example, this was equal to, what does that say it is? Minus 2 point,
The t?
negative
2.8.
2.0, minus 2.8, 067 or something? 067, okay, so I look at that. So what's that telling me?
But I need to get another shot
Here's
of
0, here's minus 2.8067. I'm testing this scenario here, so basically I'm saying, okay, what's the observed probability greater than that? And it's saying it's 0.999. So basically, yeah, I'm going to fail that test. When would I fail this test? The only time I'm going to fail this test is if this value is where? If it's way out here somewhere, right? So this is saying, okay, here's what I observed, so it's 0.999. So the only time I'm going to reject under this scenario, what does the p-value have to be? It has to be what value or less?
0.05.
It has to be less than 0.05. 0.05 or less, right? The p-value is less than 0.05 or less, then I reject at the 0.05 level. If the p-value is 0.009, then what would I do? That's a very rare occurrence, right? So then I'd reject at the better than the 1% level, right, of significance, okay? How about if it was 0.09? Then I can't reject at 0.05, but I can reject at alpha is equal to, say, alpha is equal to 90%, right? I mean, alpha is equal to 10%, alpha is equal to 10%. So basically, that's what it's telling you. So that's what the p-value is. So if I'm testing at 0.05, the p-value has to be 0.05 or less. That means it's way out in past the extreme value of the test, okay? And then what it also does, it gives me a confidence interval back in the original scale. So it's saying it's 10.29, it's greater than, since I did a one-sided test, it's going to give me a one-sided confidence interval. It's saying it's greater than 10.29. And then it also gives me the sample mean, okay? So the t-test gives you two things. If all I want is a confidence interval and I don't care about the test, what do you think what would I type in for? It doesn't make any difference. The thing I could do, if I want a two-sided confidence interval, I'd basically just say, I'd say two-sided, right? Or I don't say anything. And I just give it any old mean that I want. I can say mu is equal to 0. I just want a confidence interval. It doesn't make any difference what mu is, correct? This would just compute a confidence interval based on whatever, would just compute, well, what would it do? I guess it assumes 0.05. If I don't assume anything, I can set the alpha level here too. But basically, for a confidence interval, but whatever size confidence interval you want, I think there's an option here for, yeah, confidence level. I can have a confidence level. The default, you have to see it on your screen. I can set the confidence level right here. You can see that the default is 0.095, but I can set it to whatever size that I want. Okay. So that's the quick way of doing it.
So can you explain what the p-value of 99.997 there means? Is that there's a 99.7% likelihood that the true mean is falling at or below 11.0?
Remember, I calculated this thing before. I said, okay, what did I say it was? I said, here it is. I said it's 0.9. Isn't that the same thing I have?
Yes.
Yep. 0.9971.
So
I said, how extreme is my value?
Not extreme at all.
It's 0.99. That means 99% of the time.
You're going to say your sample is going to fall at.
That's not very extreme. It's extreme if it's extreme if it's 0.05 or less, right? Or yeah, if it's very small, right? If it's very small, it's extreme. If I did a two-sided test, now a two-sided test is a little trickier. A two-sided test, it's going to be equal to for a two-sided test, you got to be careful. So as I just showed here, what's the p-value? So the p-value of test, of t-test, say t-test. Okay, it's going to be equal to, it's going to be, okay, the scenario we just did is if we have mu is less than mu naught, and so then basically what I want to know is p-value is equal to the probability of t being greater than x bar minus mu naught s over the square root of n, okay? For mu greater than mu naught, for h naught mu greater than mu naught, that's going to be p, that t is less than, x bar minus mu naught over S over the square root of n. Okay. And for mu not equal to mu naught, for mu equal to mu naught, that's going to be 2 times P. P is greater than the absolute value of x bar minus mu naught over S over the square root of n, where I only take the positive value. It's going to be 2 times that. Why is it 2 times that? Basically, if I only take the positive value of this thing and look at P greater than that, right? It's basically I'm doing a two-sided test, so I have to get the lower tail and the upper tail, no matter what happens, no matter what T, x bar minus mu is. Okay, so it's equal to that. All right, so that's what the p-value of the thing is. We're just looking at how extreme the value is. What is the achieved, how extreme is the value that we saw? So basically this is saying, we expect to see this very often, if that's true, okay? Okay. So that's basically it for that. Now we can go, okay, we know how to do it. So now I can do a testing for a proportion. How do you test for proportion? Especially if n is large. If n is large, what can I do? If I test for proportions, n is large, and p is not close to 0 or 1, what can I assume? Testing for proportions. N is large and p is not close to 0 or 1. How can I assume what's the distribution of my estimated proportion? It's normally distributed, okay? Testing for proportions. Okay, if n is large, P not close to 0 or 1, then I can assume, yeah, there's the other one, I'm running out of ink now. P is approximately, then P hat is approximately distributed. Normal P hat okay? We did that before, didn't we?